Okay, we're looking at numbers 1 through 6 on the practice worksheet for exponential graphs, where without a calculator, we want to match the functions with their graphs. So number 1, f of x equals 2 to the x power. That's the parent graph of the exponential function with a base of 2. And that would be an increasing function. It would have a horizontal asymptote at the line y equals 0, and it would pass through 0, 1, and 1 comma b, and our b is 2, so it would pass through the point 1 comma 2. And we can see that in graph B, we have a horizontal asymptote at y equals 0, passes through the x-intercept 0, 1, and then 1 comma b. So number 1 would be graph B. Okay, then number 2 is the parent graph, but with a reflection in the x-axis because the a is negative, right? Whenever your a is negative in transformation form, that's a reflection in the x-axis. So we would be taking our graph, our parent graph from B, and just flipping it over the x-axis. So instead of our anchor points being 0, 1, and 1, 2, it would be at 0, negative 1, and 1 comma negative 2. And so that would be graph A. Okay, then in number 3, our a, instead of being negative, is a positive 4. So this graph is still increasing from left to right, only instead of passing through 0, 1, and 1 comma 2, we're going to multiply those x values by 4 to produce a vertical stretch. Okay, so when we look at 0, 1, when we multiply that y value by the a, which is 4, we get 0, comma 4. Then 1, comma 2, when we multiply that y value by 4, we get 1, comma 8. And that would be graph E. Okay, and then number 4, we have 1/2 as the a, which would be a vertical shrink. But mathematically, we're still multiplying, right? Just like we did in example 3, we multiplied the y coordinates of the parent graph by a. We're going to do that now. So 0, comma 1 is going to be 0, comma 1/2. And then 1, comma 2, when we multiply 2 times 1/2, we get 1. So we're looking for the graph that goes through 0, 1/2, and 1, comma 1, which would be graph F. Okay, then in number 5, we have the same function as number 4, only the a is negative instead of positive. So we've got the same anchor points, only after reflecting in the x-axis, this 0.5 will become 0, negative 1/2, and then 1, comma 1 will become 1, comma negative 1. And we see that is graph C. Okay, then in graph number 6, we've got to find the one where, just like graph E here, it's a vertical stretch of 4 compared to our parent graph, only it's a reflection in the x-axis. So when we look at graph D and compare that to graph E, we can see how these anchor points have the same x and y values, only the y's are negatives. They're the opposites of each other. So D is going to be our graph for number 6.